Image formation by the convex lens can be divided in 6 cases. In first case, we consider that object O is at infinity. In this case, we take a convex lens having the optical center O and the principal axis passing through the optical center. For image formation, we have to take at least 2 rays. Object is at infinity, which is AB, and for image formation, we take 2 rays. So one of the rays taken passing through the optical center, and by property, this ray passes undeviated. Another ray is taken through the focus, and this after refraction becomes parallel to the principal axis, and they intersect and image is formed at the focus of the convex lens, and this image is A dash B dash. The property of image is that it is a real image, inverted and diminished. So we can say its magnification is very less than -1. Minus refers the inverted image and very less than 1 refers the size of the image is very small. Second case is object O is between infinity and 2f. Suppose this is the convex lens with optical center O, principal axis passing through the optical center, and here it is 2f1 and f1, this is f2 and 2f2. Object is between the infinity and 2f1, so we take one ray parallel to the principal axis. This by property will pass through the focus after the refraction, and another ray is taken through the optical center which passes without deviation. So image will be formed between the f2 and 2f2, and this image is real, inverted and diminished. So we have the property of image as it is real image, inverted image, diminished and formed between f2 and 2f2, and in this case magnification is less than -1. Third case is object O is at 2f. So this is the convex lens with optical center O, and the principal axis is passing through the optical center, and this is f1, 2f1, f2, 2f2. Object is at 2f1. So for image formation, we take 2 rays, one ray parallel to the principal axis and after refraction passing through the focus. Another ray is taken passing through the optical center and it passes without any deviation. So image will be formed at the 2f2. Therefore, property of the image will be the real image, inverted, size of image is equal to object, that means magnification is equal to -1 exactly, and image is formed at 2f2. Fourth case is when object O is in between f, 2f and f. This is the convex lens with optical center O and the principal axis passing through the optical center. These are the focus f1 and 2f1, f2 and 2f2. Object is in between f1 and 2f1, so one ray is parallel to principal axis. After refraction, it passes through f2. And another ray passes through the optical center, and this ray passes without any deviation, and the image is formed behind the 2f2. So the property of the image will be, it will be a real image, inverted image, and enlarged. Size of the image will be larger than the object, and also image will be formed behind 2f2, and magnification we can say is greater than -1. Now it is inverted and size is larger. Fifth case is object O is at focus. In this case, we take a lens with optical center O and principal axis. Focus are f1. This is 2f1, f2, 2f2. Object is at f1. So if a ray is taken parallel to the principal axis, it passes through f2. And another is taken through optical center, and it becomes parallel to the earlier ray. So image will be formed at the infinity. So property of the image will be, it is a real image, inverted image, and enlarged, formed at infinity with magnification is very greater than -1. And the sixth case is when object O is between focus and optical center. So this is the lens with optical center O with principal axis passing through the optical center. f1 to f1, f2 to f2. Object is in between optical center and the focus. So one ray is taken parallel to principal axis, it will pass through the focus, and another ray is taken passing through the optical center. So this ray on backward tracing cut at a point which is the image of the object. So this point, if object is AB, then the intersection point is B dash and A dash. So image in this case is virtual because it is on left hand side and cannot be taken on the screen. It is erected image, enlarged, and magnification is very greater than 1. Now we have to draw the image formation by the concave lens, for which we draw the concave lens with optical center O and the principal axis passing through the optical center. An object is taken AB. For image formation from B, we take two rays. One ray passing through the optical center passes undeviated. Another ray is taken parallel to the principal axis and it diverges and appear to come from the focus. So the two rays cut at the point B dash and drop on the principal axis give the A dash. Hence A dash B dash is the image of AB. The property of the image is that it is virtual. It forms on the same side where object is, so cannot be taken on the screen. And this is erected and diminished. That means its size is smaller than the size of object. Magnification is defined as the ratio of the size of image with size of object, or we can write it as I by O. I refers image and O refers object, or we can write also as H2 by H1. Two type of the magnification. One is transverse magnification and it is also called lateral magnification. Suppose we take a biconvex lens. An object is placed vertically upward on the principal axis, this is AB, and a ray is taken which passes through the optical center undeviated and forms the image, say A dash B dash. Image is inverted, so magnification is I by O or H2 by H1. Here H2 refers the length of the image A dash B dash. So because this is the inverted image, so we will take it sign minus as per sign convention. So it will be minus A dash B dash and divided by the size of the object, which is AB, it is upward erected, therefore it is taken positive. Now in triangle AOB and triangle A dash OB dash, which are similar triangles because their all corresponding angles are equal. For similar triangles, their corresponding sides ratio will be equal. So we can write that A dash B dash by AB will be equal to OA dash by OA. Therefore, magnification will be equal to minus A dash B dash by AB. It will be equal to minus of OA dash by OA. And OA dash is the distance of the image from the lens, it is V, and OA is the distance of object from the lens. As per sign convention, OA dash is on the right hand side of the lens, so it is taken positive, it is V, and divided by OA, which is on the left hand side of the lens, so it is taken negative. So it will be equal to V by U. So finally we can write that magnification, that is the transverse magnification, will be equal to H2 by H1 and it will be equal to V by U. Another one is longitudinal magnification. When the object is placed along the principal axis. That means the lens is the biconvex lens and the object AB is placed along the axis. So its image will be formed on right hand side with A dash B dash. Therefore, the distance of the A dash from the lens is suppose VA dash and distance of B dash from the lens is VB dash. Similarly, distance of object point A from the lens is UA and distance of B point is UB. Therefore, the lateral magnification for the lens will be, that is the length of the image divided by the length of the object. So length of the image will be V B dash minus V A dash divided by U B minus U A. If the object is very small, in that case, for small objects, we can consider M will be equal to dV by du. So we have found that the transverse magnification will be equal to V by U and the lateral magnification for very small object is dV by du. Now using the lens formula, which is 1 by f equal to 1 by V minus 1 by U, on taking the partial differentiation, we will find that differential of 1 by f will be equal to differential of 1 by V minus differential of 1 by U. Because f is constant, so differential of a constant is 0 and differential of 1 by V will be equal to 1 minus 1 by V square into dV. Similarly, of 1 by U, it will be minus 1 by U square into du. Rearranging the term, we will have 1 by V square dV, bringing this term on left hand side, and it will be equal to 1 by u square into du. So dv by du will be equal to v square by u square. Or we can write, because dv by du we have already mentioned that it is the lateral magnification ml, and it will be equal to v by u is the transverse magnification, it is mt square. So ml equal to mt square for very small object.